All right, welcome back to the CompTIA certification course. Today we're going to be talking about security architecture. Now, security architecture helps us identify, um, refers to the design and the framework that we'll use to protect our systems. Okay, think about this as it's a security architecture to bring extra layers of defense. So we'll refer to this as defense in depth. And so, what the defense in depth does is it makes sure that even if one layer of security is breached, the others will remain intact to help mitigate damage when we do have an attack within our in our infrastructure. All right, first thing I want to talk about is on-prem. So, the difference between an on-prem versus a cloud infrastructure basically is what we're headed for here. And on-prem is talking about all data, systems, and applications, and they're going to be hosted within our own physical systems. They're going to be within our own facilities and in our own data centers. In other words, we are fully responsible for everything, including physical security, hardware, software, networks, everything. Now, what the key considerations here that we need to worry about are going to be, well, we have full control over security. They're on premise, which means we need to control security infrastructure. We need to make sure the firewalls, intrusion detection systems, data encryption, everything is to the specific needs of the business. We need to make sure that our environment remains physically safe, what it means like we have access controls, maybe surveillance systems, maybe environmental controls, and that only authorized users are able to get into the system. We need to make sure compliance and data residency. So, because we're on prem, we are going to make sure that we are held to our regulatory requirements, right? These are our compliance requirements, such as residency of the data. We've talked about data sovereignty in the data section. We can talk about privacy. And then we need to make sure, like, for instance, if we're in healthcare or finance, again, we're going to have this regulatory bodies like PCI or HIPAA to ensure that we're doing things properly. Hosting the data on site may help us ensure the compliance with laws and mandate the data storage is actually in the proper geographic locations. We're going to have greater control over our updates and patches. Now, we'll have full responsibility of it, but we have greater control of when patches are applied to systems, so that way we can have dedicated resources to manage their security posture here. And then the other thing is on-prem is the most expensive. It has the highest initial costs and maintenance costs, because not only are we responsible for the servers, we're responsible for everything, including software, infrastructure, and facilities. This means we are responsible for maintenance, power, cooling, staff. Everything is an overall expense of our system. So let's talk about cloud infrastructure a little bit. In cloud architecture, data systems and applications are normally hosted in remote locations in a third-party system like CSP, which is a cloud service provider. And these are like AWS, Microsoft Azure, Google Cloud platform, and they normally handle most of the infrastructure and security. But we as customers will still have a shared responsibility, such as we need to make sure that our data, applications, and user access is secure. Now, what are some key attributes of cloud computing? Well, we have now a shared responsibility model. We need to divide responsibilities between the cloud service provider and the customer. The cloud service provider, again, will be responsible for hardware, networking, and the physical data centers, while we will be responsible for the application data and user access. It is very scalable, though, and flexible, because now organizations, we can use what we need, nothing more, while this cloud service provider will have to make sure that they have enough headroom for us to grow into. There's a lot of built-in security services like MFA, firewalls, encryption built into cloud providers, just as you would see on an on-prem, but it's even more important to our cloud provider. You're going to see things like data encryption and access control being implemented as zero trust, because, again, we've got a lot of different clients here, and we need to make sure that only the people who should have access do have access. Now, with cloud providers, compliance and governance normally will have different standards to make it easier for us. However, we as the organization are still responsible to make sure that our data stays in compliance. Okay. Now, cloud normally has lower upfront costs, and mainly because we aren't buying everything that we need for an on prem system. We don't have physical hardware, we don't have the infrastructure. Instead, we pay as you go. So it's a lower upfront, and we can just use the resources we need and nothing more. Now, what about cloud versus on prem? What's really the big thing here? Well, we've got control versus flexibility. Because on prem, we have control over the security configurations and the physical infrastructure, but again, it's higher costs. While in the cloud, we are scalable and we have built-in security features, but we need to be very careful on how we use their information because we may not understand it 100% to maintain security. Now, for physical security on-prem, we have direct access versus in the cloud, we are no longer able to just walk down the road and go see our servers in person. Data residency and compliance is easier on-prem because we can control where the data is stored. Now, cloud providers can help you comply with certain standards, but we need to make sure that we configure it properly so none of our data goes in places where we're not supposed to. Then we've got scalability and maintenance. On-prem is a very manual and slow process to scale, while the cloud is very fast. And so what we normally see here is the hybrid approach. We call it the best of both worlds, where we'll put some stuff on-prem and some stuff in the cloud. Things that are going to be very sensitive to us, we might keep on-premise, while we may have some of the less sensitive stuff in the cloud, allowing us for scalability and flexibility. So what does cloud security look like? Well, again, we have that shared responsibility model. The CSP responsibilities versus the customer responsibilities. We do need to make sure that we understand what this model looks like when we buy into cloud services. We have IAM access, which stands for Identity and Access Management. And there are different ways of doing this in the cloud, but IAM is the most critical for security control because this is how we're going to do authentication and authorization within our environment. We can do things like RBAC, which is access roles based off of their job functions. Remember, we want things like least privilege to be enforced here. And normally we'll see MFA by default. We need to make sure data encryption is turned on, especially with the cloud, because no longer are we able to look at our hard drives and know that nobody's accessing the hardware completely. So we need to make sure that data at rest and data in transit is encrypted. We can look at our network security, and there are different ways of doing network security in the cloud, but they do things called VPCs, which is the virtual private container, which allows us to separate from customers. All our data is going to be within our VPC, and we cannot escape our VPC. Almost think of this as a virtual environment, but we are only allowed inside a virtual environment. To leave our virtual environment, we need to have traditional hardware such as firewalls or other security groups stood up. Cloud allows us to do a lot of monitoring and logging. And they do have a lot of tools out there, like AWS has CloudTrail and Azure has the Security Center, which allow us to look at all of our logs if needed. And then they normally provide us with a SIEM. Now, we can use their SIEM or we can attach it to our own SIEM. But remember, the Security Information and Event Management System is what we're going to use to bring everything into a single pane of glass. Then we've got our compliance and governance. A lot of times cloud will help us with this. They'll have different services to make sure that we are complying with our regulations. And a lot of times they'll have things like certification and audits to help us comply as well to make sure that their systems are PCI certified as well. And then lastly, we have disaster recovery and resilience. And this is where cloud probably shines the most, because most of the time you're going to have access to 3 or more data centers, and they're going to be geographically separated, so that way you could easily throw your backups from one data center to another and recover within a timely fashion. So we use cloud because, for one, it's scalable. We can use what we want and grow without worrying about procurement of physical hardware. We do it because of the cost efficiency. We do it because it's a pay as you go model. And I keep saying pay as you go because just be aware in the Security Plus, if they ask you why would you use cloud, cloud is scalable and it's pay as you go. That's one of the biggest two reasons for cloud. Now, they do have built-in security tools and they have additional resilience and availability, as we would expect, but these are also something we could build to an on-prem if we wanted to. Just remember, the scalability and flexibility with the cost efficiency is really what we go for here. So you may have learned about virtualization in your A+ class or something in that nature, but it does come up again here in the Security Plus. And so be aware that we need to understand the differences between virtualization and containerization. Okay, so virtualization itself is the process of creating multiple virtual machines to run on a single physical server. It's basically a way that we can utilize the hardware a little bit more and not waste our hardware from just sitting there running a single process. Do know that there are two types of virtualized servers. The first one's going to be your type 1 bare metal, and then you've got your type 2 software. Type 1 bare metal means that it's going to have an underlying hypervisor. We're going to have something run the hypervisor is going to run directly on the server, while the virtual machines are going to run on top of it. Versus type 2 is software. Think of this like Oracle VBox, where maybe I want to run Oracle VirtualBox on my laptop that already has Windows on it. I can install a virtual server on top of something that already has an operating system like Windows or Linux already on it. And that's a type 2. Type 1 is dedicated bare metal. Type 2 is software on software. Now, key considerations when you're dealing with virtualization is going to be, for one, we need to make sure that we have our hypervisor up to the latest and greatest and configured properly. We need to make sure that our virtual machines are isolated and they can't talk to each other unless they need to, because cross-VM attacks is something that we have to worry about. We need to make sure that our network is segmented so that way the machines can only talk to who they need to. Think about zero trust here. We need to make sure that we're monitoring resources and limits so that way a machine doesn't use too much resources. Then make sure that we have limits set up so that way if they try to, that they won't be able to. We need to make sure that we have backups. This is going to allow us to do snapshots and backup security. And again, we need to make sure we're the latest and greatest software. Why? Because patching is life. Now let's talk about security of containerization. So containerization is a little bit of a different model than virtualization. It allows us to run what we call containers onto a shared operating system. So let's say we have an operating system on a computer. We don't want to run that operating system 10 times, so instead we can run a container on top of the operating system, and all the software and libraries needed to run that application would be in the container, while it will share the operating system as an underlying OS. Now, some key things that we need to think about for security when we're dealing with containerization is we need to make sure that we have container isolation, because we don't want the containers to be able to talk to each other directly unless needed to because of their function. We need to make sure that the container runtime itself, such as Docker, is going to be secure and up to date, because the runtime itself is just another piece of software. So regular patching will help us ensure this. We want to make sure that our image security and vulnerability scanning is up to date, because sometimes we'll get these images from a third-party vendor. We didn't build the images, so are they up to date and secure, or do they have weaknesses within them? Now, containers are called immutable. Immutable means once they are made, they cannot be changed once deployed. So we can't just patch an image while it's running like an operating system. We need to give it a new image, destroy the image, and roll up a new image anytime we want to patch a container. Now, images are great, But just like VMware, we need some kind of orchestration. We need to be able to control thousands of these automatically, and that's where orchestration comes in place. Things like Kubernetes is a very popular container orchestration. Now, if we use Kubernetes, well, Kubernetes now needs to make sure that we configure and secure it as well, just because if an attacker gets into our orchestration software, maybe they will have access to everything. Okay. And then lastly, we need to think about our container networking and security, such as network segmentation, maybe a service mesh setup, or even firewalls to help prevent access to the containers or leakage from a container that wasn't supposed to leave. Okay. Now, why do we use either one of these? We've got virtualization and we've got containerization. So which one do we use for certain things? Well, virtualization is a little more resource intensive than containerization, but it's definitely better than running a separate server for every application. Now, containerization is a little more lightweight, but remember, we're sharing the OS. So what happens when I need to patch that OS? What happens when if that OS ever gets attacked? How do we limit the level of the breach? Now, with isolation, virtualization is fully isolated through their hypervisor, which helps security, but will cost us performance. Because now, remember, we're running an operating system for every one of these. Now, containerizations are isolated at the OS level, but they can also be less secure depending on how they're configured. Again, remember, they're sharing an OS. And then in flexibility, virtualization is greater for heavier workloads, while containerization is great for serverless or microservices. These are great for rapid deployment, such as web servers or any easy API-driven services. So let's talk about serverless real quick. Serverless computing is a way that we can run an infrastructure, including servers, without the use of worrying about the underlying operating system, software, and code. So really all we're worried about here is actually the code itself, not the hardware. Okay, and that's what I'm trying to get at here. It's a cloud computing execution model. In other words, this is normally done in cloud, as they're going to provide you with a front-end interface. Like in AWS, I can think of Lambda. That's a serverless computing model where I can give it code and it will execute based off of certain things. Now, those certain things could be like I could get functions as a service. Maybe I want to just have HTTP requests or file uploads. I can use functions as a service. Maybe I want an event-driven architecture. When somebody uploads a picture, I want some code to run on that picture to maybe format it properly, or a video where I want it to auto-transcode the video. Or we can have a one-time use, such as storage device, and the I can say this word, I can't say this word. Okay, it's just basically serverless functions that are short-lived. They don't remain their states. So basically, every time you run them, they're not going to have a memory. They're going to run exactly how they need to run, and they're ideal for a stateless workload. Okay. Now, key considerations when you're dealing with serverless, and think for SecurityPlus, just know what serverless is. But we need to make sure that our code is definitely secure, that those who can access it are authorized to access it. If there's any third-party dependencies, that they're managed properly, and we have those mitigated as well. If there's any security events, can we make sure that the API and file uploads and stuff like that can be tracked and secured properly? Are we using data encryption, and how are we monitoring these new functions? The next one I want to talk about is microservices. Microservices is where an application is built as a collection of small independent services, and they normally communicate through an API. Now, the reason why we use microservices is they're just really small sets of code. They're a lot easier to maintain, and if we need to make a change to a set of code, it's pretty easy to change one small microservice and not everything across the board. So we have decoupled services here. It divides all our larger applications into smaller independent services. As I said, they're going to talk through APIs, right? Which is going to be through either REST or HTTP or something in that nature. And then they're going to be something that we can easily scale. You're going to find these a lot when we're dealing with containerization, because each microservice can be developed, tested, and deployed independently at a very fast rate. and allows us to update things individually without having to go through a full testing algorithm again. So, what do you got to think about with these? Well, a lot, okay? We do need to make sure that everything is met. The biggest ones I want to point out here is probably data encryption. We want to make sure that's set. We need to make sure our API security is set properly, and our authentication and authorization is set up properly. Those are probably the big three when you're dealing with microservices. Let's talk more about what they're going to highly test you on the Security Plus would be like the network infrastructure. Network infrastructure is anything that can be comprised inside of our system. So these are the virtual servers, these are the containers, these are the physical servers. This is all of the data communication, our networking, our system, our users, our application. Network infrastructure is a generic term saying pretty much everything, okay? Now, there are different pieces of network infrastructure that you should know about. One of them would be like network segmentation. This is the ability of taking a network, separating it into smaller isolated segments or zones, and this is so we can limit the spread in case something does happen. One of the other ways that we can configure this is we can have firewalls in between our network segments to ensure that any data entering or exiting a certain location of our network can be filtered to ensure that the data is allowed to enter or leave our solution. Now, these aren't only on the external side of your network, they can be anywhere in your network, and sometimes you may have dozens, if not hundreds, of firewalls within a network to ensure that a security is withheld to the highest standard. Then you have your intrusion detection or prevention systems. These basically are just detecting and preventing malicious activity. Now, intrusion detection versus prevention is exactly in the term. One detects and alerts us, while one can actually prevent it as well. So not only is it detecting, maybe it finds an attack signature, it can automatically block it. Okay, but be aware that IDSs and IPSs should always alert somebody on their presence and what they're doing. Then you've got VPNs. These are definitely used for remote workers most of the time. This allows us to get communication between untrusted networks, such as through the internet. And we use these also with our vendors. Maybe you have another vendor you do work with, and you'll have a site-to-site VPN to ensure that both vendors can talk to each other in a timely fashion and have certain rules in between there. You're going to have firewalls still of what communication is allowed. We now still have a zero trust network access, which allows us to assume that no user is trusted by default, right? But so when you plug into a network port, it ensures that every device, user, and packet basically is authorized before it is sent across the network. We got our network access control, which is our NAC, which is policies to ensure that only certain devices and users can connect to a network. These are a little less than zero trust. They're not blocking everything, but they do a first validation of the user as you first plug into the network. We've got our load balancers. Load balancers are great to say we can have traffic that comes in from one port and go to multiple servers. We use this for high availability and fault tolerance to ensure that we're not overloading a single server. We've got our endpoint protection. Now think about endpoint protection for laptops, mobile devices, IoT devices, whatever it may be. These are going to be software directly loaded on our end user's hardware to ensure that we are monitoring and tracking things properly. We've got basic encryption, and this can be anywhere within our network. And remember, we have a couple different data states, including data at rest or data in transit, data in use. And we do like to use encryption, at least in data in rest and data in transit, to ensure that it's protected in integrity before it gets to its final location. And then we've got our software-defined networking, which is a newer model that allows us to control our network through software rather through hardware-based configurations. It used to be we do everything in CLI, right? And we would like SSH into a switch and control it from there. Now SDN is some orchestration software on the back end that will help us configure our servers, our switches and our networking gear at the same way and consistently through our network. Now, there are some security challenges as we're dealing with this. We have to make sure that our attack surface is minimized, right? Because the larger our attack surface, the harder it is for us to control. We need to make sure that all our protections are protecting us against things like ransomware, DDoS, APTs, and any new attacks that may be coming. And then as we make these networks more complex, how are we going to manage our network? So hopefully we're using solutions like SDN, software defined networking, or orchestration to ensure that we have some automation when it comes to our network configurations. And then finally, we still have securing of cloud networks to ensure that we follow the best practices there. And so we may have to leverage our cloud providers, our CSPs, such as Microsoft or AWS or Google, to ensure that our cloud networks are also secure to the highest level as our on-prem servers are. So we want to make sure that we implement defense in depth. I've talked about that at the beginning. Defense in depth is having multiple layers of protection so that we're not just depending on one layer of security. We want to adopt zero trust as much as possible. We want to make sure that we are looking at our network and regularly auditing it to ensure that it's okay. And then we want to centralize our monitoring, right? We want to use our SIEMs. We want to make sure that we're using a security information and event management system and keeping an eye on everything in a single location. And then lastly, we should probably automate our patch management. And this is all devices, including firewalls, switches, endpoints, laptops, cell phones. It doesn't matter what devices in your network, make sure they're all patched. And don't just forget about the hardware, but also remember the software itself. So let's talk a little bit more about SDN. For the SecurityPlus, the big thing that you need to know here is it is a way for network administrators to manage, control, and configure their switches and their networking gear through a centralized based software. Think of it like our SIEM for security. SDN is there for an interface for network configurations. Now, you can see different pieces when it comes to SDN, and they may be the control plane where they send all their control commands through. You may have the data plane where this is responsible for controlling all of the data within our network, including like routing devices. We might have a controller, which will then be like the brains and govern the network behavior. And then we've got all these APIs. And so we've got the southbound and northbound API, which helps us identify things like how do we configure switches, routers, firewalls, and these APIs are normally what will govern orchestration platforms, okay? Southbound is normally on-prem, while northbound, a lot of times we're dealing with cloud orchestration or security application and monitoring, okay? Infrastructure as code, you do need to know at least of the term when it comes to SecurityPlus. Infrastructure as code is the modern approach for provisioning infrastructure through code. Think of Terraform or Ansible or Puppet. These different softwares here allow end users to configure their network through an automated software. And so some of the key concepts that are common IAC is, well, you're going to have two different types of models. You're going to have declarative or imperative. And so a declarative means we're going to say we want a final state, but we don't have to tell the software exact steps on how to get to that state. For instance, if I want to set an NTP server to a certain IP address, do I need to tell it exactly how to do it? Or can I just say, hey, can you set the NTP settings to this? And if I do that, then if it doesn't need the exact step, that's a declarative model. And if it does need the exact steps, that's an imperative model. Now, IAC is going to have version control just like any software. So just in case we need a rollback, we're able to do a rollback in case we need to. And it also helps us track changes within our infrastructure. This is how we can automate and have repeatability within our systems. And then, of course, we want to make sure we're consistent, right? How do we make sure that the whole network is consistent without introducing inconsistencies or errors like humans would? So we use IAC to do that. Now, when we're dealing with the next side, we've got a couple smaller pieces we need to know. There's going to be a centralized and decentralized architecture. Centralized architecture means that everything is consolidated into a single location and or even managed from a single hub. Okay. When we're dealing with decentralized, though, there could be multiple locations. Now, depending on the size of your organization, sometimes you might be centralized, sometimes you might be decentralized, or even if you're dealing with the cloud, sometimes you're dealing with a decentralized cloud environment because you're using multiple availability zones or multiple regions of your cloud provider to spread your data across maybe globally. Okay. Now, what does that look like? Well, this is what it looks like. We've got a centralized architecture where control and management is all done from a single point versus distributed across multiples. We got a single point of failure. Well, the central point is a single point of failure because if we lose that one data center, for example, it's gone. Versus decentralized, no, it won't affect the entire system. Single point, centralized is really hard to scale versus decentralized is easier to scale. Security policies are easier on a centralized environment, but it's normally harder on a decentralized environment because the way that we want to look at this too is think of centralized versus decentralized not only as physical security here, but also how are you going to do security across your organization? A centralized organization might be one security policy that goes across your entire organization, while decentralized means every department might have their own security policies. Okay. Now, cost effectiveness on a centralized is normally more efficient because it's just smaller, right? Versus higher costs when you're having when you have duplication across multiple units. Now, performance itself can on a centralized can be experienced, but we normally can improve it upon a decentralized architecture because we have local control of the resources. Now, on resilient side, the decentralized architecture is definitely going to be more resilient because we can also operate independently versus a centralized center. If we lose it, we lose everything. Okay. They did add IoT to the Security Plus in 601 technically, and we're taking the 701 exam. IoT just means of any little physical devices, sensors, or systems that can collect, exchange, or act on data over the internet. And these are these little devices. Think of these as your little smart switches in your homes or your smart fridge or whatever it may be. These are all IoT devices. IoT devices, though, on security has a lot of challenges because the devices themselves normally are built in with limited power and processing. So they're harder for us to make sure that we're using the latest and greatest security aspect. They normally have a very large attack surface because we have a ton of them. They're normally prone to being used in botnets because we have thousands, if not millions, of these devices across the globe that are going to easily be attacked and utilized against their will. Now, a lot of these IoT devices will also have insecure communication because of they can't do certain things like encryption very well. They might use insecure data transfer, so they're easily to be read and go for. And that's where it brings us to the lack of security standards, where they're highly fragmented. And so, because of the lack of standards, it's pretty easy to get into them, but they're not very consistent within a network. It's really hard to know which ones are going to be secure and which ones aren't. And which brings us to data privacy and compliance. It's really hard to make sure that these devices are going to be GDPR or HIPAA or PCI compliant. So we do need to make sure that we segment these devices from the rest of our network to ensure that they don't interfere with our network, right? And then lastly, it's really hard for us to update the firmware and software on these devices because for one, there's so many of them, and for two, they don't normally come with regular updates, so they're harder for us to maintain. The other topic that you need to know about when it comes to Security Plus will be the ICS and the SCADA systems. Oops, my bad. Yes, we're almost to the end, but I meant to not skip that slide. ICS and SCADA. So ICS stands for Industrial Control Systems, while SCADA stands for Supervisory Control and Data Acquisition. And these systems are normally done with critical infrastructure. These are normally the things that run our HVAC units. These are the ones that can be in industrial systems. And they normally are there to do things like water, energy, treatment, transportation, utilities, all these kind of things. And the security challenges with these kind of systems are kind of like IoT devices. They normally are harder to deal with because a lot of them are going to be legacy. they run on technology like Modbus. And these older technologies are prone to man-in-the-middle attacks or eavesdropping because they are not encrypted. Now, these older technologies also, people are not going to just replace their HVAC system in their units, so in their buildings, and so these legacy systems must be maintained. Now, they sometimes will have isolation issues because they may not connect to your network in a very secure fashion. And even if they do connect, sometimes they might be fully air gapped. So they're harder to do remote monitoring and maintenance as well. Now, we have some physical and cyber threats here that we have to think about, meaning like if a cyber attack does get into one of these devices, now we're talking about environmental hazards or even human life. Because even if it's just an HVAC and they just crank the heat in your data center, that's one thing. But what if they start affecting power grids or water treatment plants in a large scale environment? They could actually cause harm to humans. Now, we also have insecure remote access. Remember, these things are old, so they normally have weak authentication, lack of encryption, or just configured very poorly. Because a lot of these companies might be out of out of business, so there's going to be limited patching. Sometimes no patches available for these systems, and so their risk of exploitation increases. And then lastly, we need to think about supply chain vulnerabilities because a lot of these devices are made in multiple vendors and smaller vendors, and so they're easier to compromise, and the attacker can introduce malicious code or hardware into the hardware of the systems. So let's talk about embedded systems. Embedded systems are specialized computing devices designed to perform dedicated functions within larger systems. That's the definition. Keep in mind of this. It's not an ICS or a SCADA. While ICS and SCADA could have embedded systems themselves are all talking about real-time operations. They want to respond to inputs or events with strict time constraints, making them very predictable, and the performance is very critical for us. Now, these embedded systems really have limited resources. They're very constrained on their resources, and they're designed to be single functional, which means they are not designed to run on broader systems, so they're easier to crash if you try to make them do something they weren't designed to do. These embedded systems are also meant to be a long life cycle, which means they're going to be installed and forgotten about. These are the ones that are going to be in older systems, and remember, we're not going to have updates for these kind of systems because, well, they're meant to be a long life device. So we're trying to make them single functionality, and sometimes embedded systems can be designed properly and they're very secure, while other times they're very insecure. It all depends on who designs them. And these embedded systems also are designed to be a lower power consumption to ensure that they are very power efficient. Okay. And so we talked a little bit about the security concerns, and if you have to take anything out of the embedded systems chapter, make sure that you just know that there's limited resources for security because these are designed to do exactly their task and nothing more. They really don't have any overhead for doing anything else. So normally encryption is an afterthought, and it's not something they can add into these devices. So that brings us to insecure communication, right? We won't have encryption. We might be easily be manipulated or exploited by attackers. They're not going to be patched very much. And they do have some physical access vulnerabilities because they normally don't have authentication or authentication control. If you can get physical access to these devices, you can normally manipulate them to do something else. So that's the end of the section for this video. We'll see you on the next section. Remember, with SecurityPlus, there's a ton of terminology, so make sure you're going through your flashcards. Make sure that you understand the terms and where they're used. And I'll see you for the next video.